Guys, so we have last half an hour in our lection, and I understand that you are getting tired after listening us for 2 hours. Thank you very much for this. So my part will be much easier and I hope a little bit entertaining. So just relax and enjoy the demonstration. Our topic will be simulation inside four walls. Dmitry have observed what kind of objects we usually have in supply chains, such as factories, ports, warehouses. And I will specifically concentrate my demo around warehouses because it's very, very popular currently. Okay, let's start. AnyLogic. I will speak about AnyLogic, our general purpose simulation software, which is multi-scale and multi-method. What do we mean saying this? At the right of the slide, you see a kind of set of pictures. They are sorted along the abstraction scale X. Let's go from the lowest, let's observe models from the lowest level of abstraction to the highest one. Here, on the physical level, the lowest possible, the lowest supported level by AnyLogic, we have models where physical distances, sizes, amounts of objects, resources matter. Good examples include warehouses, uh, everything which connected to pedestrian models, let's say a shopping mall, a train station, or a production facility. If we go higher on this abstraction scale X, we will find large logistics. For example, a port, a rail station, or a road traffic route bound. If we look higher, we will see the map, and this is where AnyLogistics plays. So map and agent-based models where we have all supply chain objects connected by different means of transportation. And on the highest level of abstraction, we have economical models. For example, models that predict oil prices or federal exchange rate or something like this. You may guess that different methods are used to simulate different models of different abstraction level. For example, agent-based is applied in all the areas, while system dynamics can be applied only for the abstract strategic models and discrete event modeling in some way here. So there are three dominated methods, and we support them all in AnyLogic, and that is why we call it multi-method simulation. These three approaches are combined by a unique library set, which includes road traffic library, rail library, material handling library, pedestrian library, process modeling library, and fluid library. So 6 vertical libraries. And it really makes AnyLogic a very flexible tool, very powerful and applicable in all these application areas. So with this said, give me an opportunity to switch to browser. So I will just open a browser, Chrome. It can be any other one. And this is cloud.anylogic.com. It is our execution environment hosted in Amazon. And you can experiment with models in it. You can run them. Models are uploaded here by many users. It's not just our models. For example, best community models, and one of the first one is oil supply chain. I will start with this. I will run it. An animation will appear just in a browser. And I will make it full screen. And what do we see here? The picture is very much like the pictures you have seen in logistics. So it's a map, GIS map, interactive, and there are supply chain nodes on it. What is the difference? It's a typical question. What is the difference between AnyLogic and AnyLogistics? They really intersect in application areas. In AnyLogistics, you can create models quickly, as Dmitry has shown. In AnyLogic, it's much more difficult to create models, but you are less bounded, you're less restricted by the application. For example, here in this model, various means of transportations are supported. We see vessels here, we see oil pipelines, and we see trucks. So not only trucks, but also other means of transportation. We can click on an object, we can go inside, and you can see how this object is created. So it's a tank of oil and other blocks from special library to operate with fluids. Let's look at the statistics which is collected from this model. Statistics include inventory levels for all these products for oil and the Gantt chart which shows out of fuel situation. Okay, let me switch back to the main page of the cloud and show you another model. Best model by AnyLogic team, and this is container terminal. You're in Singapore, so a relevant topic, port simulation. This is a particular type of port container terminal, which is, to be fair, is a frequent object to simulate. This model has beautiful 3D animation, and you can change cameras. For example, this is the main camera, and author of this model also said predefined a lot of other cameras, which we can switch between. By the way, beautiful 3D is also a kind of trend. All people who played computer game, being child, they really demand having beautiful animation for simulation model in business. All the processes are simulated, and you see this is a little bit different scale, much lower. Here we already have cranes, and these cranes shouldn't intersect in this space. And we have particular objects such as containers. We have equipment like these trucks, which is limited, and all of this affect the simulation results. Okay, let's look at the results. Statistics. We can control the speed with what the model runs, the coefficient between real time and the time in the model. I will ask model to run as fast as it can so that we collect more statistics. What we have here, an idle time for trucks, Q, not length, but time which trucks stay in the queue on average, and also some timings. In each of the model, I will show you the statistics because I think it's important. By the way, without run of the model with animation, we can run it without it, and we can look at these outputs on a dashboard, because AnyLogic Cloud is not only execution environment, it's also a kind of dashboard for model experimentation. And if somebody already ran this scenario, it will not be executed again. It will just be gotten from the database. Okay, our next model, and I will go to transportation and logistics category and choose another port model called grain terminal. Grain terminal. So it is not this. No, it's another terminal. Grain terminal. So I will use search. Yeah, this one. It is also about supply chains, but here supply chain object is simulated with much more details and with a focus on how the supply chain node operates internally. Why it is important? Because very often your modeling environment, like AnyLogistics, gives you the results of network optimization that a particular port should have a throughput, let's say, 10,000 containers per week. But we should understand how it affects the facility. And with such detailed simulation, we really can learn how our facility will work with this throughput, whether it will be enough or it should be extended. Okay, this is also an interesting model because here we see railroad, and the silo, the grain is unloaded from this train, and conveyor is used to transport a special bulk conveyor, special object in AnyLogic, which is transferred to tanks. And we also have truck transportation here. And also, if you wait for some time, we also will see the vessels which will appear at these piers. Yeah, you see? And then grain will be uploaded into it. As always, we have 3D animation which we can rotate, we can set different angles, etc. Also, we can look at the same model in 2D. Sometimes it's even more, I don't know how to say, it gives you more insights, and sometimes not. Okay, as always, let's look at the statistics. Inventories and utilizations. You may already notice that they are rather typical for simulation models. Okay, then the next model which I will show will be route bound. Maybe I will choose just road traffic here. Yeah, road traffic is a specific category. I remove filter. By the way, you can open cloud.anylogic.com yourself and experiment with the same models being at home after our lecture. And this is already a model from low abstraction level. First of all, I should say it looks like a game. I may place a camera on the car, and something like a game from, I don't know, 20 years ago, but still, it's 3D, and you can see that cars really follow physics rules. For example, when they change lanes, they are not going one through each other. And such models are also very useful in business, not only in civil engineering. In business, companies, production companies, simulate roads which are connected to their facilities. For example, you have big production facilities with multiple buildings, and there are roads in between, and there is some fleet to transport goods, raw materials, and finished goods, and people simulate this. By the way, another instrument I want to show you is a density map. So you see roads are now highlighted, and the roads with junctions, they are highlighted by red color. So color depends on the car density. Okay, the last but not least, statistics. Number of car in system, number of stops per car, average speed, average time in system. Okay, that's it. I hope you understood that there are a lot of models from various application areas here in AnyLogic Cloud. It's just a website which works even on your smartphone. With this said, let me switch back to the presentation. Do you see the slide?
No.
No? Second, please.
Their animation.
Okay, I will stop sharing.
Yeah.
And I will share my screen again. By the way, I don't have this animation running, so it's a kind of Zoom artifact. I even don't know how to reproduce it. Please share.
Everything's okay.
Okay, we observe models from different levels. of different abstraction levels. Models where details matter and models where we abstract away from all the details. Let's go further. What we also have just seen, different set of statistics. Let me summarize. Typically, simulation models provide efficiency metrics such as throughput, service levels, quantity of orders, shipments, etc., cost, operational, salary, cost of equipment being idle, utilization, resources statistics, and it allows for different configuration testing. Let me then speak a little bit about warehouse simulation. First of all, I should say that it's currently very popular. It's booming. Why? Because companies around the world utilize automation. And this automation should be checked. We should somehow measure the performance of the future object before we implemented expensive hardware and software being installed in our facility. That is why companies use simulation. We don't know any other way to understand all these new automation technologies in work to estimate their effectiveness and, I don't know, calculate return of investment. What else people use simulation for in warehousing? Resource optimization. Imagine that you have a peak of demand in each December or each Black Friday. You may simulate how your warehouse will work on this demand peak and make decisions like, for example, get more people, introduce more people to the warehouse. Then inventory policies. Yes, Dima has said this. Simulation models are used to check different inventory policy or even to optimize them. Capacity and throughput. I have touched this topic. We often know the throughput, but we don't know the capacity, or vice versa. We know the configuration of our code, but we do not know what is the maximum throughput it can operate with. And the last is CAPEX decision, capital expenditure. So when we invest something, let's say in automation, we should simulate to understand which ROI we may have. So it's typically a part of standard procedures when, for example, a new port is designed. In many countries, simulation is just a necessary part of the technical, economical research which is done before the construction. Okay, how simulation model of warehouse may look like. On this slide, you may see a model animated in 3D. This warehouse is typical, I should say. And this type of animation, 3D one, is also typical. What we have here, different zones, trucks which arrive, forklifts and humans that operate inside the warehouse. You may notice that currently the animation switched from one 3D to another 3D. This is what we call omniverse integration, because the animation which you see now is designed in Omniverse and it is animated by AnyLogic. So AnyLogic calculates all the movements for all the objects, and animation is in NVIDIA environment. In general, I should say that being engineers, we don't think that such detailed animations are necessary. But a lot of managers really require such level of details. And also, the demand is driven by NVIDIA, by computer games, and by general perception that virtual reality and good 3D really is our future. We in AnyLogic also a part of this trend. Okay, on this slide you may see typical inputs and outputs of warehouse simulation models. I will not go in details through each of the items here. It's just here for your reference, that in the future you may also understand what you need to start simulation of a warehouse. And as outputs, as always, we have quality metrics like delay times or percent of orders shipment and time, costs, utilization for staff, equipment, and different zones of the warehouse. Okay, let me then switch to AnyLogic. This is AnyLogic development environment. You see, AnyLogic Professional, and this is its welcome screen. From welcome screen, you can go to example models. And I will show you just a couple of examples to give you this perception how such models are designed, because you already know how models are set up in AnyLogistics. Here we have completely different way, much more complex and also visual. So a picture worth 1,000 words, so I will show. I will go to manufacturing category and choose fulfillment conveyor system. You see there are three zones here. This one, and this one. So three vertical areas. And when the model is loaded, here we see project. It's a kind of tree with all the objects inside our model. Well, in the central area, we have the model itself. So it's a big canvas with multiple areas which we can switch between. For example, this is the model layout, and we can go to, I don't know, to another animation elements. We can go to 2D, and this is the logic. And I should say that logic of this model is really simple. And because it's simple, I will spend 30 seconds to explain it to you. First of all, the model is defined by a flowchart. Blocks connected with connectors. We get this block here from payload, and we have different payload. For example, source block generates orders, generates entities. Some entities which represent agents, payloads, trucks, etc. It can be anything. And we get this from process modeling library. The next block is moved by conveyor, and you see it is colored differently. You may find this color here, and you will read that it's the material handling library, full of blocks of different nature. Here we have conveyors, HVs, transporters, warehouse racks, etc. So we just convey this box and it disappears. Or it may go to another line. Here it has a branch by different conveyor, and it again disappears. So the most simple model. When we click on the object, its property appears on the right. For example, here convey has target, which is defined. It's a name of the block of the particular layout element. Okay, let me run the model from here. The same window which I have shown in the browser will appear, and you will see the same, absolutely the same type of animation, but already on your desktop. This is a big warehouse facility, something like postal service, companies like DHL or a lot of different postal services has such simulation models. As in the previous model, we have different workplaces which we can switch between. Everything is animated is in 3D, runs fast, and the conveyor network here, in my opinion, is really sophisticated. Okay, and I will show you one more model. So I will go back to welcome screen, and I will show you a model called transporters moving in a free space. So I will run it. I will open main object. This is a small facility. Layout is much smaller than in the previous model, but the logic is much more complex. So you see, there is no direct correspondence between the layout complexity and the process complexity. Okay, let me run it. I show you this model because I want you to have this vision. What are the typical objects to simulate? What are the typical objects inside models? What people do care about? And here you may notice AGVs. So this is automatic robots that are moving just on the floor with no lanes. Sometimes they have lanes, sometimes they have not. AnyLogic support both. They get boxes from the conveyor and put it into some machine. And in general, they are central point for this simulation model. They are charging here, and all the transportation in this model is done by different robots like this one and this one. So in warehouse, they also operate. Classical forklifts, manual ones, are shown here, but they never used because of automation. Okay, you have seen the logic. It's also animated. We can click on objects to see what is inside. For example, this object, this conveyor contains 9 items. And the same typical statistics, such as waiting times and density map. So despite this model is not about road traffic or pedestrians, it's about manufacturing, but the same approach, we highlight high density areas with different colors is used, and this is typical for simulation. Okay. You maybe think that's it, but no. The last point I want to show you is our website. And by the way, we have a webinar on February 11th. This is a kind of ad, but why not? Let's go here, resources, case studies, because there is a proven way to learn. Learn by experience by other people or companies. If we want to know more about warehouse simulation, we can go to and read and watch the case studies by companies like Walmart, who also simulate AGVs, DHL, who simulate e-commerce warehouse, about pharmaceutical company with small items, not boxes, about famous 3-4PL provider Kuehne+Nagel, who optimized picking, the same picking optimization by DHL. We may learn what Western Digital, computer hardware provider, do with simulation. So all is inside. I will show you only one case study. And I think it will be the cherry on our pie of warehouse simulation. So what we see here, Brown Shoes is a Canadian famous network, distribution network for shoes. In 2015, they implemented automated storage and retrieval system on their new facility. SRS is something like this. So this is automatic model which where we have no transportation, no even robots. Everything is automated, only conveyors and special cranes. If we switch back to our cloud and we search here for warehouse, there are such models. All models. Warehouse and this one, a model by our Japanese client. This is not the model from the case study, but it's very much alike. And by the way, if you look to other models by the same author, they all are very interesting, and they all about warehouse hardware equipment and configuration. So this is how ASRS look like. So there are special cranes that move objects. And all the transportation are done by them, and boxes arrive to them through conveyor network. And this conveyor network also connects the system with forklifts that help goods to get out from from a warehouse. Okay, I'm switching back to the case study. I hope you recognize the same type of object. It looks I should reshare my screen again. Stop sharing and share. So I hope you recognize this object. So brown shoes had this facility, and they wanted to test a different configuration. And you may notice that this configuration is much stronger. So they implemented an additional conveyor lines and a lot of stations. Much more complex conveyor network connected to the same ASRS. And with simulation, they were able to understand that their warehouse currently had such average throughput, while the new configuration with 6 stations and 2 conveyor loops is designed in the way that maximum throughput is much higher. Okay. Each of such case study is accomplished by a video where companies deliver the speech themselves. And this is a case study by one of our biggest implementation partners, Simwell, a global company, originally from Canada, and Brown Shoes, a Canadian retailer. Okay, I'm switching back to the presentation, and my last slide will be about business value of simulation. Dmitry already delivered this you in a really well spoken English with a lot of metaphors like simulation is like a computer game. My metaphor would be simulation is like a crystal ball. It allows you to see the future. So you have a real object, you create its simplified representation, and you have picture like a computer game, and also you have results if you see the future. And if we compare it with network optimization, which was shown by Alexei, network optimization suggests you the way to implement supply chain, what nodes you should have and what will be the flows between them. It's another type of magic, real magic that creates an answer for you. Here, it's just a vision, so you can it doesn't give you the answer, but it allows you to test any scenario which you may have, which your colleague may have. If we all disagree, for example, with Dmitry and Alexei, we can simulate our 3 scenarios and we will really know what scenario is better. So it's also a great communication technique. With this said, I want to finish, and please do not hesitate to open cloud.anylogic.com yourself and to see the other models. Do not hesitate to visit our website anylogistics.com and anylogic.com to download a free version which will live permanently on your computer, and consider using our products in your educational activities. So a lot of people based their master thesis, their PhD thesis based on simulation. Or even if simulation is not your focal point, it really helps because it allows you to predict the future, allows you to do virtual experiments. Thank you. If you have any question, please ask.
You got any questions? I think you stunned them into silence, Sergey. So that they've done well, and you've done well to take it for 2.5 hours. Thank you very much. So I want to thank you and your team, for always supporting us in the class, and it gets so better every year. So thank you for your support. Let's give them a round of applause. So when's your next trip to Singapore, Sergey?
Thank you. I promise to be there.
Okay.
And if you want, guys, each of you have a chance to contact us. Just write info@anylogic.com or use contact form on the website. You may tell that you was participating in this lecture, and you can address your question directly to Alexei or me.
Thank you. And I'm surprised you didn't show the document we did together. Do you remember the white paper on humanitarian logistics, right?
For sure. But I have mentioned humanitarian logistics. Guys, go to AnyLogistics.com. It's one of the most popular case study because it has humanitarian impact, which was done by Logistics Institute Asia Pacific and presented by Robert de Souza in America on our conference. So you have everything.
Thank you so much, Sergey. Thank you. So we log off now. Thank you, and we'll see you soon.